Hi everybody, this is Michael, and for this physics video we are going to cover combination circuits with an example and an MCAT-like question. This video is an extension off of the previous video where we covered parallel circuits with an example and a series circuit with an example. So the first thing that we're going to do is talk about combination circuits for resistors. So a few tips that I like to give are look to combine two resistors that are not separated by a junction. And I like to start with the parallel circuits just because you have to use an equation that is, like, I guess, a little bit more difficult rather than just adding them together when you have a series circuit. So if I was given this compound circuit, I'm just going to look to see what do I want to add together first. So I have two parallel resistor circuits right here. And then once I find the equivalent resistance of these two parallel circuits, I will have two series circuits, this one being in series with this one and this one. So the first thing that I want to do is, like I said, solve for those these two parallel circuits here. So from the video previous, we know that the equation for solving for the equivalent resistance of parallel circuits is R1 times R2 over R1 plus R2. So I'm going to go ahead and solve for that. That will be 5 ohms times 3 ohms over 5 ohms plus 3 ohms. So that will be 15 ohms over 8 ohms. And that will give me an equivalent resistance of 1.88 amps. So now that I have the equivalent resistance for that, I can go ahead and essentially just consider this parallel circuit to not exist and rather just include the equivalent resistance here. So now I'm going to solve for the equivalent resistance of the parallel circuit, the second parallel circuit. So that would be 8 ohms times 7 ohms over 8 ohms plus 7 ohms. So 8 times 7, that would be 56 ohms over 15 ohms is equal to 56 divided by 15, which is 3.73. So now I have the equivalent resistances for both of these two parallel circuits on the top. So I can just, like I said, imagine that these parallel circuits are no longer existent and we just plug in a normal resistance for each of these. So now I have three resistors in series. I have the 10 ohm resistor, the 1.88, I'm sorry, this should have been ohms here for both of these since it was the equivalent resistance. So I have the 10 ohm resistor, the 1.88 ohm resistor, and the 3.73 ohm resistor. So I know that for in series, I just have to add the three resistors together to get the equivalent resistance. So that would be as easy as doing 3.73 plus 1.88 plus 10. So I'll just plug that into a calculator and I get 15.61 ohms for my equivalent resistance of this entire combination circuit here. So the question asks, find the current through resistor 3. So if I want to find the current through resistor 3 and I have the equivalent resistance, if I consider this combination circuit now a series circuit because I had three resistors in series, then I know that current remains the same through each of these resistors because they are in series. So I can use the equivalent resistance and I can take the voltage of the battery and I can solve for the current that will be going through each of these three resistors equally. So that would be current is equal to 20 volts over 15.61 ohms, and that means my current will be 1.28 amperes. So like I said, because the combination circuit, I now made it in series, I know that this 1.28 amperes is going to be consistent all the way through each of the resistors. So that would be equal to the resistor of, equal to the current going through resistor 3. So that's everything you need to know for solving for combination circuits in series. So now we're going to get to the MCAT-like question. So the question asks, if the resistance of the 3 ohm resistor in the circuit below is quadrupled, how will the total current in the circuit be affected? So what you can do, you can go ahead and pause the video if you'd like to solve for yourself, or you can watch how to solve it, or how I go about it. So what I know is this 3 ohm resistor is going to be quadrupled. So I need to solve for the total current using finding the equivalent resistance of this compound circuit using this 3 ohm resistor and using the 12 ohm resistor in its place. So what I'm going to do is to find the equivalent resistance first, we need to break it down and solve for its parts. So I like to solve for parallel circuits first, like I said. So now I'm going to solve for the equivalent resistance of this parallel circuit using 3 ohms and 12 ohms. So that would be, I know the equation is R1 times R2 over R1 plus R2. So I'm going to go ahead and plug that in. That would be using 3 ohms. That would be 3 plus 6 over, or I'm sorry, 3, it would be 3 times 6 on the top, and 3 plus 6 on in the denominator. So that will give me 18 over 9, and that would be 2 ohms for the equivalent resistance. So now I'm going to do the same thing using the 12 ohm resistor in its place. So that would just simply be 12, sorry the stylus is messing up here. So that would be 12 times 6 over 12 plus 6 is equal to 72 over 18. And so the equivalent resistance is 4 ohms. So now I have 2 ohms and 4 ohms for this parallel circuit. And since this parallel circuit is now in series with the resistor 2 ohms here, I need to take 2 ohms and 4 ohms and add them separately to 2 ohms to find the equivalent resistance of this in series over here. So what I'm going to do is I'm going to take 2 ohms from right here, and I'm going to add it to the 2 ohms that it's in series with right here, and that will give me an equivalent resistance of 4 ohms. And this 4 ohms is the equivalent resistance using 3 ohms for the resistor in parallel. So now the other, so using the 12 ohm resistor, that would be 4 ohms that I calculated here, 4 ohms plus the 2 ohm that it's in series to right here, and that will be 6 ohms. So since it's asking for the total current in the circuit and how that's affected. So if I want to find the total current, I know that in a series resistor, the current remains the same between both resistors. So I'm going to use the 12 volts that are provided by the battery and solve for the current using both 4 ohms as the series resistor and 6 ohms as the series resistor, and then see how those compare. So using 12 volts divided by 4 ohms, according to the equation I equals V over R from Ohm's law, I know that the current running through the circuit using the 3 ohm resistor at the top is going to be 3 amperes. Whereas by using the 12 ohm resistor, I'm going to use 12 volts divided by the equivalent resistance that I calculated. So that will be 12 volts divided by 6 ohms to give us 2 amperes. So now I have the current running through the combination circuit for both the 3 ohm and the 12 ohm resistor since it's quadrupled. So now I just have to identify how these compare to each other. Is the current decreasing or is the current increasing? Obviously, I know that the current is decreasing here, so now I can already eliminate by process of elimination that C and D are incorrect. So now it's just a matter of using algebra to solve for what factor is it decreasing by. So now I can plug in this 2/3 first. I'll do 3 amps, which is the current using the 3 ohm resistor, times 2/3. Well, that's as simple as crossing out the 3, and I know that that is equal to 2 amps. So I already know that A will be the answer. So if you have any further questions on combination circuits, or if you prefer this MCAT question, just let us know so we can include it in the next video. So thank you for watching, and that'll be it.